Okay, so I'd like to welcome everyone back here who joined us, and for those of you who just showed up here, I want to take a moment here and welcome you to the latest in our Design World webinar series. And you're here for the webinar titled "Fire, Pressure, and Ice." Oh my, a little drama in there. Motion control in hostile environments. And I want to welcome everyone here. And just a few housekeeping items prior to starting here. So this webinar will be available afterwards at designworldonline.com and also through email. So everybody who's registered for the webinar will receive a copy of the webinar through their email. I also want to let everyone know that at the end of our presentation, we will have some time for a Q&A. So if at any time during the webinar you have a question that pops into your head, you can go ahead and list it there, and we will do our best to get to your question. And also, if you're on Twitter, you can also live tweet this webinar as well using the hashtag there, hashtag DWWebinar. So that's some of the housekeeping items. As I've mentioned already earlier, I'll be the moderator for this webinar. My name is Miles Budimir. I'm the motion control editor for Design World here. And our presenter today will be Hack Summer. And just a little bit of background about him. He is the Applications Technology Manager at Moog Animatics. He's been with Animatics for about 13 years. A little bit about his background. His technical training includes U.S. Navy nuclear engineering, mechanical engineering, and electrical engineering. And he has over 20 years experience in the automation and controls field, including a number of areas or projects, if you will, advanced drive and motor design, machine design for semiconductor manufacturing, biomedical, CNC, as well as some military conformance design and conformance testing. So he brings quite a wealth of knowledge and background to this topic. And with that, I think I'm going to hand it over to Hack then. So you can begin whenever you're ready.
Okay, thanks a lot, Miles, and I hope everybody can hear me okay. Thanks for the introduction. Yeah, what this is going to focus on is basically the harsh environments, or not necessarily as harsh, but not your typical mainstream environments for automation. A little bit of a background. Moog Animatics, founded in 1987, it was acquired by Moog Components Group, a division of Moog Corporation, just recently, 2011, just a couple of years ago. Moog Animatics, basically, we are kind of the automation branch of the components division, and what our company division does, we handle programmable servo motors and actuator lines as well. We also have the accompanied cables and power supplies and whatnot to complement these products. You can see a screenshot of a few things there. We do not necessarily handle sealed actuators for harsh environments. We do focus on the motors. The two motors left, just in from the far left there, are the sealed version motors, or some of them anyway. So let's get started here and talk about it for a moment and see what we've got. Make sure my control is working here. Oh, there we go. A little bit of a delay on my end. Okay, how fully integrated motion control solutions are the secret weapon. You know, we're looking at wet processing and washdown environments. What I mean by secret weapon is basically something you can get that that not many people are aware of. A product that's a little bit different, a little bit of a different edge in how you can design your machine or apparatus, whatever it may be. So not many people know about it. Basically, I'm here to give you an idea of that. Okay, integrated motion control systems save design money, money for machine builders in the industry, and they provide a special set of benefits for those in wet processing. What I want to do is go over this and give you an idea of what's really going on. Okay, because of the idea of an integrated motor, there's a little bit different way of approaching things. What I'd like to do was approach what happens in a wet environment. I accidentally went one notch forward, but let's go ahead and get into the wet environment here. How do we even look at a wet environment? First off, there's a protection you need to have against condensation, for example, in an application. Okay, and in condensation, you apply heat or internal board level heating. Okay. Out of that, complete sealed motors would be one thing. Okay, consider sealed shaft, or positive pressure force air cleaned air into the enclosure. Now I mentioned, board level heating or air into an enclosure. See, this is where our product differs a little bit. Unlike where you just buy a motor, say, I'll just throw some names in the air from, Baldor or Leeson or somebody like that. It's just a motor and it's sealed. We're the motor, drive, and control all in one. Now, if you have a cabinet or enclosure in these wet environments, they also have to be sealed. So we need to consider condensation that may form inside that sealed cabinet, whether it be due to change in pressure, or when it cools down in the evening and starts up in the morning, it has sucked in moisture overnight. So what we are providing is a possible solution that gets rid of that extra cabinet space that may need further sealing. Okay, so let's look into this a little bit more here. Okay, washdown environments. Now these washdown environments are of various types. You show a few pictures here of various environments, including an oil rig. Okay, machinery rinsed usually with water or chemicals or mixture thereof. It could be medical manufacturing, semiconductor, packaging, food, or beverage. Okay, naval, fresh, brackish, or salt water. That also needs to be considered, because when you get into brackish or salt water, now you're also talking a corrosion issue. Okay, rain, sleet, or other outdoor environments. What if we are outside? If you're in an area where it gets very cold and then the temperature changes later and gets warm, or vice versa, there's more to consider there. Entertainment. We show a little picture down at the bottom of water displays, SeaWorld, Las Vegas, other places like that. Now we deal with shock hazard with exceeding OSHA level voltages for water displays, for example. So it's not just water that may be in a washdown environment. We need to go into a little bit deeper and see what we've got there to work with. Common washdown environment problems include issues with cabling. Okay, temperature and humidity already mentioned, and components connection points. How many places do you actually connect these cables where it may be subject to the temperature and humidity? Machine and machine replication costs now become a problem. Let's suppose that you have, instead of one axis, you have, say, 20 or 30 axes. Okay, we're selling motors here, and I need to get cables to each one of those, and every one of those goes through that temperature and humidity and has connection points, whether it be through a stuffing gland through the wall of an enclosure, or whether it be an actual connector. Okay, we need to consider what it's going to cost to replicate this machine. If it's not just one machine and it's 100 of them, it's going to cost a little bit more on this. Okay, tips for these wet environments. How are you going to handle those? Okay, properly identify IP rating. That's first off. Okay, is it truly a wet environment, or is it a washdown environment getting rid of something in process that happened earlier? For instance, maybe what we're working on is, I don't know, stuffing crackers into a box. Well, the crackers need to be dry, but maybe later they need to wash it down to get rid of the cracker products or whatever. Okay, we don't want that to have an issue here. Okay, so I don't want the wrong IP rating to where all it is a rinse down and drip down from the top down. It may be a case of it's submerged or partially submerged. So let's think about that. Look at the IP ratings table for a moment. Okay, the IP ratings, it consists of letters or numbers, I should say, the first and the second number. Now, I'm not going to go through painstaking repeating of everything you see on the screen here, but let's just suffice to say, if your IP rating is 00, there is no protection. Okay? If it's the first number is basically ingress of solid objects, and what I've said before is, IP 0 means, a pelican can probably fly into it. So we need to be aware of that. IP1, protects against solid objects of such size. It finally gets down to IP6, totally protected against dust ingress. Okay? The second number is about liquids. Okay? And under the case of liquids, what you're looking at is no protection there again, lowest number, and highest number and protection is all the way up to 8. So if we have a sealed motor, I will tell you that typically, if it's sealed against certain types of humidity or liquids, then probably it's going to be sealed against solids as well. What we've got here is it's typically going to be a 6 in the first number. The second number may be 65, 65, 66, 67, or 68. So the second number would be 5 through 8 typically. Okay? What we offer is a IP65 at a minimum. And this is protection against low pressure water jets from any direction. Limited ingress permitted. It says permitted. Okay, that implies that if it's 65, there actually may be water getting into a product. I will tell you that we personally internally don't permit that. Okay, now a lot of people may confuse it because at this point, 65, a lot of people say that's washdown. Well, it's low pressure water from any direction. It could be coming down from the top down. A lot of people think it's splashed or maybe it's just dripped. Actually, that's a lower protection than 65. If you do look down at 61, it says protection against vertical falling drops. A lot of people will confuse IP65 with IP61. 65 does allow low pressure spray from any direction. Okay? If you look down a little bit further, you got protection IP66, 67, and 68. 67, or excuse me, 66, that second number, 6, means high pressure, okay, not low pressure. 67 and 68, some people confuse these as well. 67 says it can go under, immerged, okay, 1 meter deep for up to 30 minutes, but it does not mention that it's operational while it's submerged. Okay, it just says it can handle it for 30 minutes. After that, hey, it may be a problem. It may come in through the seals of the shaft or whatever. IP68 is one that truly can run, actually operate underwater or under this liquid for an extended period of time. It's hermetically sealed. Okay? Not everybody needs that, but a lot of people would like to have it. So what we just need to understand is whatever that sealing protection is, make sure it fits what your true needs are. Okay? The first number being about solid products, the second number being about liquid products. Like I said, typically if it can handle the liquid, it can probably handle the solid. So I just want to make sure that's clear. Okay, why temperature isn't the only concern for aerospace applications and what is? Now the reason I bring this up is a lot of times we will get applications that include aerospace up on a jet, on a helicopter, or wherever. Okay, let's consider what's going on. High altitude. Okay, if it's aerospace, chances are it's on a jet. It may be in or outside of the pressure hull of that jet. Okay, obviously if it's outside, the pressure may be a lot lower. Okay, low pressure means low density atmosphere. Now, that low density atmosphere has an effect that not many people are aware of. Okay? Low density atmosphere at high altitude can cause other problems that people may not even consider. If there's low pressure, it actually affects the components within the product. Okay? I'm trying to get this thing to zip forward here. Okay? High altitude includes aerospace, military, and commercial. Okay? Its locations are often overlooked. High altitude by electronic specifications could mean as low as 3,000 feet or higher. And where this thing about low pressure comes in, electrolytic capacitors are used in the drive stage of many drives of servos. Okay, these electrolytic capacitors, when rated above 3,000 feet, the specification actually goes down. Okay, the capacitance actually goes down with pressure. So what's not known by many manufacturers or not made blatantly obvious is that when that pressure goes down, your capacitance to give surge current into the motor goes down. The result is you don't have as much drive current for peak applications. I mentioned Colorado. If you look at Denver, for example, Denver, Colorado is sitting at 5,000 feet. Okay, at 5,000 foot elevation, you've actually had to degrade the rating of that motor, okay, or that drive motor combination. Issues arise not only because of temp, but low pressure. I'm sorry, I didn't get that thing forward for a minute. Think of a race car at sea level. It needs high octane gas. At Denver, gas can be a lower octane at this elevation because it burns faster, kind of like water boils at a lower temperature at a higher elevation. The same with the motor. The dielectrics don't work as well. Low pressure environment. Okay, I'm sorry, I did have a technical difficulty there for a moment. For whatever reason, it didn't tip through. So, okay, tips for higher altitude. Consider if the application is within the pressure hull or external. A moment ago, I mentioned the airplane or a jet. We have motors on jets right now. Some of them are internal to the pressure hull, some of them are external, meaning they're exposed to, say, 35,000 foot elevation where it's cold and low pressure. Okay, if it is external, consider larger capacitors, as I mentioned a minute ago, for the power supply stage. Okay, also consider board mount heaters. Be aware that the controller for the heat up may need to be inside the pressure hull. Even though we supply heaters for the circuit boards or for the motor or the electronics, well, the motor and electronics have to be preheated or held at a temperature ahead of time. Okay, so what we do is we provide on one particular product an external connector to provide external source power to an internal heater, in which case that may come from inside the pressure hull of the jet. Okay. Okay, what is the normal operating temperature range for motion control products? Of course, obviously you see a picture there of a lot of ice. Well, that's cars next to a riverbank, okay? That may be normal for where you live. You may be up in Minnesota, or you may be up at, somewhere in Alaska. Motor electronics are, oops, we got a typo there. Motor electronics are limited to 85 C, typically, okay? However, many are 70 C. Some of them are actually even lower, down at 40 C. These are electronic components on a circuit board, okay? There are certain reasons that they're limited as such, okay? However, most motors are typically limited to 125 degrees C, okay? In our case, we have 125 degrees C motor, but we have electronics tied to it. And in the case of our product, it's limited to 85 C. We went for the highest level sustained temperature we could get in our components on our circuit boards. Okay, integrated motor drives are thermally limited by those electronics. That means if you have a 125 C motor, you actually have a reduced torque continuously because you only allow it to heat to 85 C. However, if you look at our torque curves, they are rated at 85 C. So what you see is what you get with regards to those. But you do need to thermally delimit if the atmosphere is actually warmer than, say, 25, which is our base. Okay, we heat up from a 25 to an 85 C rise, 60 degrees. If it happened to be, say, 55 degrees C ambient, then you're already 30 degrees into that 60 and you're delimited by 50% of capability. A lot of people don't think about that. So you need to understand you may have to thermally derate a motor. Okay, low and high temperatures. Now we mentioned extreme temperatures here, and I just did mention the fact that we're limited at 85. What we do have is a low temperature range, extended range motor. Okay, locations for those may be biomedical, where you would have to have that lower temperature, being cryogenic. Okay, semiconductor manufacturing, where they have very cold temperature, may even be in a vacuum. We'll get into that in a moment. Oil and gas industries, topside down, downhole pipe exploration. When you go down deep, it actually gets cooler. Okay, environment near furnaces. Now this gets to a hot side. An example, carpet placing example with motors sitting in an open furnace. That's where they're forming carpets outside a furnace for automobile applications. We've done one of those once. Okay, condensation and humidity issues. This is caused by, rapid change in temperatures. Yes, it can be. If you've got something that's very hot, goes to cold at night and back to hot during the day, moisture will condense on the surface of those products. It may get inside of the products, in which case your means of feedback with, such as an encoder, optical encoder, you wouldn't want to use a standard optical encoder where that could happen. You may have steam from hot washdown to kill bacteria, okay? But that's not sustained typically. So that's a case where somebody will say, can you handle boiling water? Well, let's think about it. A motor can handle 125 C. Yes, it can handle boiling water. The electronics, 85 C sustained. If you wash it down with steam for a moment and it goes away, chances are it never heated up above 85 anyway, and it's not going to hurt it. Okay? Cold temps, those include, say, juice filling machines that cannot rise above a certain temp. This is a case of, say, an apple juice factory where they keep the apple juice chilled, but they fill up bottles with it. All of that's within a chilled area. Okay, There again, condensation, that can be deadly for an optical encoder, because if it condenses on the read head, you can't read it. Okay? Water vapor ingress. Motors and drives create heat when they run, warming and expanding the air inside. When they're powered off, the air cools, creates negative air pressure that can pull that latent water vapor inside unsealed crevices. Okay? Always be aware of that. We've had multiple people that say, machine ran great during the day, but the next morning it runs horrible. That's because overnight it actually sucked in that moisture and caused problems. Okay? Tips for that low and high temperatures. Airflow. If you install it in a location near a heater, consider adding airflow to shield from the heat. Okay? If transitions occur from high to low and back, consider dried air force feed to keep condensation from occurring. In other words, feed it some dry, clean air. Okay? Low temperature normally occurs, consider a constant heat source to prevent mechanical binding. Now, when I say mechanical binding, we've had an occasion where somebody pops a gear head on the front of our motor. The next morning they come in and they're somewhere in Minnesota or Alaska or Toronto, Canada, and it's cooled down. The motor didn't have the problem. The gear head actually contracted and started binding. So what they did is they allowed the motor to stay warm overnight, and there's some tricks to that with PID constants, and it allowed that gear head to stay, in an expanded, or I should say normal rate of expansion. That way it wouldn't bind. Okay? So consider this. You may have to have that heat source in a cold area. Well, you know what explosion proof really means? It's another extreme environment. Okay? A lot of people call us about explosion proof motion control systems. Explosion proof, what it really means is if volatile gases get within inside the product, within the void, and they are ignited for whatever reason, okay, it will contain an explosion within that product. Okay, if you take a motor housing and internally, for whatever reason, you get an arc inside of there and it had, say, pulled in methane gas, well, if it ignites that methane gas within that motor, it should contain that ignition. No flames should come out of any part of that casing or housing anywhere. That's truly what explosion proof means. It does not mean that if you had it sitting in a bomb shelter and a bomb goes off that the product will be okay. It also does not mean that the product's usable after this occurred. So if a product absorbs in, say, methane gas or natural gas or some explosive powder, and then it does ignite within it, it will not spread out of it. However, it may be a useless product after that because it causes internal damage. Okay, so explosion proof does not mean that it will explode internally and still be okay. That's what I wanted to get across on that one. Okay, tips for explosion proof environments. Okay, let's think about it. Look at the regulations, okay, for the area in question. Is it a volatile gases or powder or dust? Which one is it? Is it, say, methane or natural gas? Is it powder, such as gunpowder or something like that? Or is it dust that may be flammable? Now think about it. Some dust may not be flammable, but it may be something you can ignite, such as aluminum powder, okay? Magnesium powder, for example. Is it all volatile gases and no oxygen? What if it's 100% methane or natural gas, say in a pipeline? Okay, within that pipeline there is no oxygen. You can strike an arc welder inside of those and have rolling robots that go in and weld cracks inside methane and natural gas pipes, and it will not cause an explosion because there is no oxygen. Okay, if the environment is oxygen free, no detonation can occur. Okay, so in other words, you can actually run a non-explosion proof product within a pipeline. See if positive force fed air may meet specifications as well. Okay, in this case, you may just have to feed positive feed air into the product so it cannot absorb that. See if the motors may be coupled through a protective barrier to the load. For example, what if you have an enclosed housing where some process has to go on inside of a natural gas or methane environment or some gaseous environment, and you need to move something around? You may be able to magnetically couple a rotating shaft through the wall into that enclosure. Okay, so there may be a way to do that. Okay, which hostile environments benefit from integrated motion control systems versus conventional motion control systems? There again, it comes back to a mentality of how it was done in the first place. I touched on this at the very beginning. Wet environments where reduced cable and components lower the system cost. With our product, you don't have a separate encoder and drive power connection to a motor with two cables going to it and then back to a controller, and you have to seal the drive and controller. In our case, it's all sealed within the motor. The only thing you really need to send out to it is power and possibly communications. The good part about that is we are below 50 volts. We're below arc level voltage that may cause other issues. Okay. Low temperature, high altitude, where no additional drive or controls would need to meet specifications. Let's say you're hanging outside of a jet. Obviously, if they want to add something to that jet and move things around for whatever reason, they don't want to have to add an entire control cabinet out there either. An integrated motor supply, a motor product would ideally fit that because the drive and control are already on it. Okay? Let's see. Wet environments where voltage should be below 50 volts to prevent shock hazard. That's not a minor one, okay? That's pretty major. If you're in an area where you know it will get wet, this includes maybe water jet cutters. It could be a washdown environment, or it could be literally something that's always on a water display, such as the things in front of Las Vegas hotels, okay? You don't want somebody getting shocked when they touch the cables if it did happen to seep in through the cables. Now, I will say that there's some little tricks you might want to help yourself with on there. You have to seal those connectors on any motors regardless with a dielectric grease just to prevent anything from causing a shock through conductive liquids. Okay, what questions to ask when buying an extended temperature range product? Okay, and then we show kind of a cryogenic deal off to the side. What is the actual environment? Okay, is it cold or is it hot? What is the duty cycle? If it's cold, duty cycle is not as much of a big deal, but if it's hot, it is. Okay, if the environment is very warm outside of an oven or in an oven perhaps, or anywhere where it gets extremely hot, which may be Saudi Arabia out in the desert, whatever. Okay, how long does the motor run, vice how long is it off? How long is the heating effect, vice how long does it have time to cool down? Okay, that's what the duty cycle is about. Okay, what other things you need to look at? Total expected change in temperature. I just mentioned Saudi Arabia or a desert. Okay, a desert temperatures can get quite cold at night, but quite hot during the day. The thermal expansion and contraction over that system is key to sizing these components properly. Can they handle the full range, and can they handle the full range of thermal expansion as well? Okay, what is the humidity? Worst case. I don't care about best case and how low it gets. If it's dry, I'm fine. But if it's moist, if it's above normal office atmosphere, then you may have a humidity issue. For instance, I'm down near Charleston, South Carolina right now. It gets very humid outside. It's like walking into a soup kitchen, but in an office environment, it's fine. So is your production facility controlled environmentally with regards to humidity? Do you keep it below, say, 40% relative humidity? Okay, the point on the humidity is, does it reach dew point? Does it reach the point where condensation actually occurs on surfaces? I can tell you for sure that in a normal office environment, in most working environments, if you set a cold motor on your desk, will humidity condense on the surface of that motor? If it's a warm motor and running, or if it's at room temperature, you should never get condensation on the surface. Obviously, if you have a glass of ice water there, it may condense, but that ice water is at near freezing or below freezing. So normally your motor will not be below freezing, and it shouldn't condense on it. Okay? I think we're getting towards the end of the slide, and I hope I didn't go too fast for anyone. Download Integrated Solutions for Harsh Environment white paper. You can go to animatics.com. We have white papers on the harsh environment products that we have. Please go there and make sure you look at those white papers. We've got some people that have put a lot of work into those. At this point, I think we're going to get Miles back online and start to open it up for questions. And our contact information is also shown here. And just to close out a little bit more, you can go to moog.animatics.com or just animatics.com, and also at smartmotor.com to get a copy of what we're doing here. It'll be posted in a few weeks, as well as other white papers. Okay, Miles, are you back online there?
Yep, I'm right here, and I just want to say take this opportunity here to say thank you to you, obviously, for that very informative presentation. And I think what we can do now is we can begin to open it up to some questions there. So once again, if you joined us a little later, you'll see there that there's a tab for questions, which you can type in any questions you may have for Hack, and we'll try to get to them. We'll try to get to them as many as we can. So let's see here. Let's see if we can start it off here with some questions, and you can post those at any time, basically. So. All right, so let's see here. I guess I can kind of start it off here. So it was a pretty good overview, I think, where you also drill down into some very specific questions. Can you talk about maybe any of the most extreme types of applications that you've seen? Maybe whether that's in terms of temperature or pressure or any of those other variables.
Yeah, let me mention a few applications just to be give a heads up. We have been outside pressure hulls of jets. We have met specification to be above 35,000 foot elevation. Okay. Mm-hmm. And the low pressure associated with that and low temperature. We've got some halt tested environment products that have been stored down to minus 65 and cold start at minus 45. Okay, mm-hmm. We have external heater connection supplied to those to where you can heat it up to minus 45 and be off and running. Mm-hmm. Okay, with regards to vacuum, I mentioned pressure. If you get all the way down to vacuum, you cannot dissipate heat in a vacuum. We do not have vacuum rated products. But what I will say is, with regards to the pressure, vacuum, sealing, and whatever, it is the standard product put in a much better housing, so you get all the benefits of the smart motor that we've always had, which include, position mode, velocity mode, electronic gearing, electronic camming, and fully programmable. So the biggest advantage is you've got all that control capability within that environment, whatever that environment may be. Mm-hmm. I do see one question that came up about exploration or rigging environment. Yes, we have been on a few of those. Okay, we've been on some that are oil rigs. We actually have been on those. It's usually topside, not submerged. Mm-hmm. I will say that there was a strange environment working on basically cutting and tooling out for turbine blades, and it was actually submerged. Believe it or not, it was running submerged on that product. Uh-huh. We've also been on some products such as, atmospheres where it wasn't necessarily the type of atmosphere you would expect. Ceramic resin slurry, okay, poured all over the boats, and yet it still worked quite well over the motors. The ceramic resin slurry, however, that becomes a mechanical issue because it's actually abrasive to the shaft, okay, and the shaft seals could break down. But in these cases, typically we are seal coupled to a gearhead, so it actually moves that sealing necessity out to the gearhead shaft. So that is one thing I didn't mention earlier. Most applications with servo motors are gearhead reduced. If they're gearhead reduced, look at the sealing rating of that gearhead and make sure you properly seal between the motor and gearhead at the flange level. That may mean gasket material, silicone RTV, or some other sealant between the motor and gearhead. This way, anything that gets in would have to make it all the way through the gearhead to the motor, and by gosh, if it makes it through there, chances are the gearhead wouldn't last either. Mm-hmm. Okay? Okay. We also have something about pipeline crawlers. Yes, we have done that. There was an Alaskan pipeline crawler application up in Alaska, obviously. It did have a wide temperature range. It ran quite well. Ironically, it was not our sealed product that was used on that. It was a standard product, and yet it still worked quite well. At one time, we had a sealed version of the standard product, and now what we've done is we've moved forward to try to get those applications into the new sealed motor applications. Mm-hmm. Other applications similar to that, we've also been on bottling lines, filling lines for detergents, liquid detergents, bleaches, things like that. We have been in those atmospheres as well. We've also been in clean room. Now, clean room is not typically a harsh environment. That's actually a clean environment. But nevertheless, that also shows that we don't have debris coming out of the motor as opposed to going in it.
Right.
Okay, we've used seals that don't break down and cause debris to mess up the clean room specifications.
Mm-hmm. All right. There's another kind of a general point here too, I think, or maybe just a question. Maybe you can add something to this, but it seems like one of the things that are critical for anyone working with any application really is to really understand and know what application you're actually working with, and then that way, I think it kind of leads you to ask the right questions, so to speak, right?
Yeah.
So you know then that you're going to get the best solution or the best product for your for that case or for that project that you're working on, basically. Because a lot of this did sound like basically do you understand where your motor is going to be used ultimately, right? So you understand
Yeah.
what the temperature is. Do you understand what the duty cycle is? Do you understand
Exactly.
you know so I don't know if you want to just add to that or maybe reinforce that point too. I guess because I don't know how often you get questions like that or how often maybe people
Yeah,
call
yeah,
you.
we do. Yeah, and
Yeah.
and to give you an example of those, we'll get applications that are anywhere from a standard pick and place machine, which you'd say, well, is that adverse environment? It may be if it's picking and placing fruit in a warehouse outside, an open door warehouse, or a pan and tilt, which could be a security camera, or even weapon systems or whatever. Well, that
Mm-hmm.
pan and tilt for a security camera may be inside of an airport, but it may also be on a moving vehicle out in the rain or on a boat, for the military, in which case it's got salt spray on it. So, yeah, we've been on those types of applications quite a bit. Keeping in mind that you get all the benefits of the programmable smart motor, that's really not part of this discussion, but it allows fully programmable capability within a sealed product in that harsh environment. So you don't have to seal up the control cabinets and drive cabinets like you normally will with other products, making it a lot more compact.
Mm-hmm.
Mm-hmm.
Okay. Here's another question about earlier you had mentioned something about the connection point there between gear heads and motors, and you had mentioned some tips or tricks basically for that.
Yeah.
Could you talk about a couple of those maybe, or kind of mention
Yeah,
what you
yeah.
had in mind?
There's not just the gear head to motor, but also the connectors to the motor. Okay, we have connectors on there. Typically is the M12 type or M16 threaded type connector, depending on the size of the motor. Uh, on both cases, on the mechanical end where the shaft goes out to the gear head, I would put a gasket sealing or gasket material in there, whether it be silicone RTV or something else. You can't
Mm-hmm.
always use silicone in all areas because there's certain atmospheres where you can't have that outgassing. Uh, that sealing should be quite, made necessary for that environment it's in. But please do not forget about the connectors, the electrical connections, because a
Mm-hmm.
lot of people will say, well, the motor's sealed, the connector is an overmolded connector, but they don't think about that void between that cable connector and the motor connector. Okay, you screw that on or thread it on, or whether it's a bayonet type, depending on which product we've got, uh, you can get in seepage through that small void. You should always put dielectric grease in there. Dielectric grease is a non-conductor that will displace the ability of water or other vapors to get inside of it.
Okay, that's a good point. Hmm.
Okay, and you know, there again, our motor or product has the ability to communicate motor to motor, product to product. You can actually rig out, say, 10, 50, even 100 axes between them, and any one of those motors can be a master. So when you connect these cables, you put that dielectric grease in there. Now you got one motor that's master out to up to 100 other motors. You don't need that control cabinet. Now,
Mm-hmm.
I also mentioned the 50 volts low voltage spec or below shock level voltage for OSHA. There's
Mm-hmm.
actually one other specification I did not mention. It's a water specification, such as in displays, whether it be a fountain or a or water display of some sort where people can actually touch the water. There's a lower voltage spec at 30 volts. All of our products have 24 volt rated torque curves. You can look it up and see what your torque would be if you kept it below 30. That's a further limited spec below the OSHA shock level that says a person may come in contact with this product in the water. Maybe it's something that moves in a swimming pool, a nozzle that, pushes water around or sprays around, whatever. In that case, we actually meet that specification as well. Okay, not many people have those applications, but if you're, say, at a theme park or some display in front of a hotel, as I used earlier, definitely you need to meet that below 30 volt spec, and we do in fact meet that specification.
Okay. All right. All good tips there. Once again, I want to remind people that we still got some time here, so if you'd still like to post some questions there, feel free to do so, and we'll see if we can get to all of the questions here. The other thing was when you were talking about some of the applications for airplanes as well. There was quite a bit there where the focus really wasn't on the motor itself, but really more on the electronics for the controllers or for the drive.
Yeah.
Would you say that that's probably more of an issue than actually what's happening with the motor, or is it just not? Do people kind of not think about that more, or is it the opposite? Do they tend to think more about the electronics and circuit board and less about the motor?
Well, honestly, it's a catch-22 on our product because our product contains a drive and the controller, so it contains the circuit boards. And some people say, well, I bought a motor, the motor's sealed, I'm ready to go. Well, when they buy ours and it's sealed and it's ready to go, it's actually the controller and drive. What they may not think about is, I want to buy this motor. I want to put it on, say, a pan and tilt outside of an airplane or a helicopter. Oh, wait a minute, I need the drive and controls to penetrate the hull internal to the pressure barrier. Well, now you have all these cables that have to go through that pressure barrier. Your cost of penetration into that area goes up. With our product, the only thing you have to get out there is communications and power. That's it. Okay, so it actually lowers your system cost. If you have, say, like I said, a pan and tilt, that's at least 2 axes. Maybe it's an aperture and focus control on a camera. That's possibly 3, possibly 4 axes running on it. Or maybe it's a weapon system where it has multiple axes on it. In these cases, still only 2 penetrations, power and control, and it may be in a single sheath cable. So we actually lower system cost in that case because all of our electronics are on that sealed housing motor. So it definitely will save you in those cases.
Okay.
Okay, I think one just popped up here. Deep submersion applications, pressure equalized for depth. Right now, we do not presently have what I would call a void-filled motor application. We do not have one where the actual void within the motor is filled up. We have done some where we fill the void for the purpose of ingress of volatile gases to try to meet explosion proof, but we have not done it for the purpose of high pressure. So unfortunately there, you may have to go somewhere else to get something that's truly high pressure, or it's a liquid filled application. There are actually motor companies that allow salt water internally because it's all potted and they have special seals on the bearings. But in our case, we don't quite have that right now. Okay. I think that's probably about got us there, doesn't it?
Yeah, I think so. It sure looks like it here. So I guess we can kind of wrap things up here. And once again, I want to say thank you, Hack, for your expertise today and for your time as well. You shared some really good quality technical information that I'm sure our registrants here and readers are certainly going to find useful in their day-to-day work. And as a couple of parting points here, I want to say thank you to everybody else who joined us here today. And once again, just to reiterate some points, that this webinar will be available at designworldonline.com and through email as well. So everybody who signed up will also get a copy of this webinar through email. We still have the hashtag EW webinar available on Twitter. So if you're tweeting about this webinar, you can do that. Ways to connect with us here at Design World. Certainly on Twitter, you can follow us at Design World. Our Facebook page there, facebook.com/engineering exchange, or you can find us on LinkedIn and Design World Group. And we also have a YouTube channel as well where we post videos and interesting things. And we can also discuss it at engineeringexchange.com as well, and also hack there. His email and contact info was on there as well, and will be as well with the in the webinar presentation that all of the registrants will also get as well. So, so I think that probably does it then. Yes.
Okay, and I will say there was a couple of questions there that popped up after the fact. If you want to close it out now, we can. Otherwise, I can't answer the last couple of questions that popped up.
Oh, okay, sure, yeah, sure, yeah.
Yeah, there's one. Yeah, someone mentioned heated ovens.
Yeah.
Yeah, we actually have been inside of ovens, and what they did is they positive air fed into the motor inside the oven. We actually ported out a hole in the motor, and we put positive 3 psi air pressure within the motor. It worked quite well. There was another question, are there other products other than the Smart Motor within Moog Corporation? Absolutely. Moog Corporation has an expanded aerospace and defense division that has literally down to the point of rocket launcher nozzle control. So yeah, we've got a lot of other products that are outside of the normal division within the animatics section of Moog. So definitely look on the Moog website and you can find those. But you know, heating, basically if you keep the ambient down within the motor or fan cool it within that area, it should be fine. You know, but I would not sit there and try to run a motor in a constant oven temperature all day long. That isn't going to cut it. Then you truly do need a specialized motor. But
Okay.
I guess that's about it.
Yeah, it looks like it. Okay. All right. Well, Hack, thank you once again, and thank you for all the folks that joined us here today. And we hope you have a good rest of the day and a good rest of the week as well.
Okay. Thank you.
All right. Okay. Take care, everybody.
Bye.